All right, so the assignment I think is something like 1 through 10 and 12 through 40. And like I said, because we were slow yesterday, and it was took me a little bit longer than what I anticipated, which is okay. Let's try to work these through. Remember, I'm trying to tell you, it's no value if you're just writing things down. All right? So here we go. Some of them I think are pretty easy. All right, yeah. All right, so 1, 2, 3, 4 is just, do you remember the rules that you were taught in 6th grade? All right, so I'm highlighting 1 and 8. Now you can abbreviate on here too. All right, 1 and 8 are called what? Alternate exteriors. Good. 2 and 4, those were what? 2 and 4. Now, sometimes if I forget, here's how I try to teach kids. All right, are they alternate interior? Are they alternate exterior? Are they consecutive interior? Are they consecutive interior? Now remember, consecutive interior just means they're both on the inside. I don't care, just throw it in the garbage. All right, that means they're both on the interior, right? Are both of these on the interior? So they must be now what? Corresponding. That's how I used to do it if I forgot something. I want to make sure you understand what alternate interior means. Right? That's an easy one. I want you to understand what alternate exterior means. Everybody agreeing with me on that? All right? And then the other one is consecutive interior. I think you should know those. Which just leaves us what? Corresponding. And remember, corresponding is the one that's on the same side and on either on top or below. All right, now what do I mean by that? Look, 2 and 4 is on the right side and above the transversal. Does everybody agree with that? That's why it's corresponding. They could both be on the left and below, or on the left and above. Those are the corresponding. All right? So now let's talk about 3 and 6. Everybody tell me 3 and 6 are what? Alternate interior. 6 and 7. Consecutive interior. Exactly. All right, consecutive interior. All right. Now, if angle 1 is 94, this is how I like to tackle this. All right. If angle 1 is 94, let's go ahead and just put 94 right there. And you can just visualize with me. All right, I think that's good. You don't have to draw it out. You can just write the answers off of my picture. All right. So again, just to make it a little bit more clear. Now, what angles are 94 degrees? Say.
Angle 3.
All of the what?
Alternate exterior.
All of the, thank you for that. All of the odd numbers. All right, now again, you guys were correct also. But I'm just saying, if we're looking at it, I also like to try to tell kids that 94 is obtuse. Do you agree? So I just remembered it. All the obtuse angles are what? Equal. And all of the acute angles are what? Equal. All right. And if you ever were looking at an obtuse and acute, they were always what? Equal to? They're always equal to 180. All right, those are your choices. They're either equal or they add up to 180. Those are the only options. All right. So I like kind of the way this figure is. All of the odds are what? 94. And all of the evens then would be 86. I think 86. All right. No, remember, we're not doing that anymore. You're allowed to make a mistake. All right, without being mocked. All right, 86. That's what we got. All right, any questions with the odds being 94 and the evens being 86? What? Well, because it's just the rules that we learned yesterday. First of all, 7 is vertical, so you know that's the same. Then you know 3 is corresponding with 1, or 3 is alternate interior with 7. Those are equal.
Oh, okay.
And then 5 is vertical, or it's corresponding, or it's alternate exterior. All right? And then what's true about 1 and 2? They are supplementary. They form a linear pair. Linear pair just means two angles add up to 180 degrees. All right? So now we're good. Anybody have any other questions with that? All right? So that, to me, answered 5, 6, and 7. All right? That answered 5, 6, and 7. Remember, if it's odd, it was 94. If it was even, it was 86. All right, here we go again. Angle 4 is 101. So in this 101 right here, again, we now can say what? All the evens are 101. And all of the odds are 79. Now it says kind of list the postulate. All right, now I want to make sure you guys hear me on this. All right. Again, I found this a little bizarre, and I remember, like I said, always argue with my geometry teacher because it didn't make much sense to me. All right. Corresponding angle is a postulate. Corresponding angles is a postulate. Everybody hearing me? Corresponding angles is the postulate. Alternate interior angles is a what? Theorem. Alternate exterior angles is a what? Theorem. All the others that we just talked about are theorems. The one that you have to accept as true is the what? Corresponding angle postulate. All right, hold on a minute. The corresponding angle postulate. I'm trying to make that clear. All right. Now, what made it upsetting to me was that there was no way to prove that the corresponding angles are congruent. We just have to accept it as true. But then when we solved everything else, or we proved the alternate interior angle theorem or the alternate exterior angle theorem, we were able to prove it using the corresponding angle postulate. Does anybody else, does that bother anybody else, or you want me to explain why that's troubling? We can't prove that this is true, correct? There's no way to prove that's true. But when we write a proof, we're going to prove it using a postulate. So what would happen if that postulate were not true? Then the proof that you just proved was true is actually not true. All right, does everybody understand that? All right. But they're saying just based on all the observation that the corresponding angles are congruent if you draw parallel lines. Is everybody with me on that? All right, and I'll demonstrate more exactly what I mean in a few minutes. All right, so remember, corresponding angles, that's the postulate. All right, everything else is a what? Theorem. All right, so here we go. Let's see what's next. 12. All right, so now in this particular problem, let's look at, just write 12 down and then just tell me x is equal to, obviously, 125. Thank you, guys. All right, thank you. 125 degrees. Everybody good with that? And then what's true about y? So to me, what would be easy if I just said y equals x equals 125? Is everybody okay with that? You write it differently if you want. Thank you, Gavin. What?
Oh, never mind.
Good? And again, like I said, please ask. Don't sit there. All right, if I'm not crystal clear, you tell me. Come on. And don't just let me do the problems and write it down and you go, wow, this is a great day in geometry. You just gave me all the answers. Because I'm not going to give you the answers on the test. What?
Why can you do y equals x equals 125?
Because they're all equal. Do you agree with me? If you don't like that, you can just put y equals 125. Right? But that's sometimes you'll see on standardized tests. All right, that notation. Okay, so 13. X equals what?
94.
Oh, might just... Someone else tell me.
114.
Yeah, thank you. X is 114.
Oh, I missed that.
I'm not sure what y'all are doing on that. It's okay. It's all right. Like I said, make a mistake. Better make it now. You're trying. You're thinking. Those of you guys who just wrote down 114 without giving it a thought, you missed an opportunity. What? What do you want it to be? Tell me what's true. Here's what I'm trying to get to you, and I'm glad you're asking, okay? So what is true about this angle right here, Dalton? And all right. Easy. What? What's true about this angle right here and this angle right here? Very good. So what's the problem? I'm not. Remember, it's not what you're thinking right now. You said you were. It's not right, correct? Would you agree? What did you just tell me about those two angles? They're equal. So write on your paper, those two angles are equal. How would you write that? What did you write? Shh. I don't want anybody to help her. What would you write? Beautiful. Wow. There you go. All that screeching's got to your brain. All right. Now, 14, I've got a real problem with 14. Why do I have a real problem with 14? I have no idea. Yeah, I have no idea what they're talking about. All right. So I'm going to say they're here. That is for that angle. That's what I'm hoping. All right. And this is for this angle right there. Okay. Now, again, I'm expecting your brilliant mental math to come into play here. All right. And just, you can write the equation. Sometimes that'll be helpful. All right. But totally unnecessary, in my opinion. What, Gavin? 70. I got x equals 70. All right. X equals 70. All right. Now, again. All right. I keep trying to tell some of you guys, if you're not sure, you got to speak up. And what's upsetting to me is the same people for 2 years have been answering all the questions. Right? Come on, speak up. I want everybody to speak up. Girls, you don't usually say much. All right? Get involved. Boys, the ones that you're not talking, you need to speak up. Tell me. And then those of you guys, before you have a question, think about what we're doing. All right?
I'm confused how x equals 70.
Okay, so what's this angle called right here, please? And this angle, what's their relationship?
They're
what are they called?
alternate exterior.
Close. Alternate interior, yes. Alternate interior. What's true about alternate interior?
They're equal.
Now, how did I know they're equal? Because they're both what type of angles? They're both... Well, no. Listen. Listen, when I'm asking you about that, I'm asking you about the relationship between its sides. Right? This is what I tried to tell you earlier. You can look at the angles and see if they're supplementary or if they are congruent. Because they are both what?
Equal.
Well, I mean, I haven't measured them. I don't know that they're equal, but I know they're both what? No, definitely not.
Obtuse.
They're both obtuse. They are both obtuse. They're both obtuse. Because they're both obtuse, that makes them what? Equal. So now in your head, all you got to do is say 2x minus 15 is equal to x plus 55. And solve that equation. Right? Make sense now? I don't even know who asked me, to be honest now. All right. Is everybody okay with 14? Everybody good? All right, here we go. Ugh. I mean, I don't think it's necessary, but they tried to confuse us here. Right? So I want to ask somebody a question here. I want you, everybody, to pay attention. 5 and 8, what are those called? Weak. Weak.
Oh, consecutive. Of course.
Still weak. Still weak. Very weak. Oh, very good. They're obtuse there. I'll give you that.
Where's 5 and 8?
They're 5 and 8.
5 and 8. What are they?
They're numbers.
That's right. They're nothing.
Angles.
Right? There's not always a relationship. There is not always a relationship. All right, that's what I'm trying to get at. All right, now they drew it in this particular way to just try to throw you off. There is no relationship between 5 and 8. All right, if I said, what's the relationship between 5 and 7? You could now say those are consecutive interior. Now remember, corresponding is the one where they have to be on, both are on the top or both are on the bottom, both are on the right, that type of
But they
situation.
can't be like on one side of the other.
That's exactly right. That's why they call them alternate. If they're on opposite sides, they're alternating. All right? They're either alternating on the exterior or alternating on the what? Interior. All right? Now, this, believe it or not, is probably the figure that'll be on the test because it's the most what? It's the most confusing. All right? So let's see how brilliant we are. All right, everybody look at, we'll just do number 15. All right, 4 and 9. What are 4 and 9? Everybody, come on. Corresponding. Very good. It's okay. Hey, just leave them alone. Leave them alone. We're not going to do that. All right? And I'm going to get my yardstick out, and every time somebody does, I'm going to smack them. All right? Then you'll learn. All right? Then you'll learn. Come on, Patrick. Remember, somebody walks in the room, same thing. It's not a matter of, wow, everybody's got to see who it is and make some. No, just let them come in and sit down. And stop interrupting me. All right, here we go. I want to look at 5 and 7. 5 and 7, those are what? Consecutive interior. Consecutive interior. Now, be wrong. I'd rather you be wrong now than on the test. How is 4 and 9? Very good question. Good for you. Ready? 4 is here and 9 is here. They're on the right side and they're above or on top. You good now? All right, here we go. Let's try 3 and 5. What are 3 and 5? Alternate interior. Exactly. Alternate interior. All right, now you should be judging yourself now on how many you get right. What?
Why is 3 and 5 alternate interior?
Okay, so here we go. I know. I heard you. This and this. Now, the reason why most people have trouble is because of this reason right here. That's in the way. Now, can you see their alternate interior? Yep. You see what I mean? That extra line messes people up. So on your test, cover it up if it's confusing you. All right? Here we go. Now, let's try 10 and 11. What's 10 and 11? Corresponding. Good. What's 1 and 6? 1 and 6 are alternate exterior. Right? 1 and 6 are alternate exterior. 6 and 8. Alternate interior. Alternate interior. Good. On the inside of the lines. So I'm going to highlight. I'm going to highlight 6 and 8. Here's 6. Here's 8. Here are the two lines right here. All right. Here are the two lines that we're referring to. These two lines. It's on the inside of those two lines. All right. So now I'm looking at 2 and 3.
Consecutive interior.
Consecutive interior. Right? What? Good. Very good. Corresponding, one is on the exterior and one is on the interior. Consecutive interior means they're both on the inside. All right? Are we on 9 and 10? Angle 9 and 10 are alternate exterior. Yes. And like I said, that's confusing because of that fourth line. All right, 4 and 11. Alternate exterior. 7 and 11. Alternate interior. Tell me.
So you said that for corresponding, it's interior and exterior, but we put corresponding for 15, and they're both exterior.
Okay, which one do you think I made a mistake on?
Well, like you said.
No, I'm asking you. I didn't.
Know, like you said, corresponding is for interior and exterior. Because Charlotte asked, "What's the difference between corresponding?" I'm asking you, which one am I looking at? And then 15.
15. Okay, so this one. Okay, so now I'm gonna erase up here. I gotta look. 4 and 9.
You said both, but they're both exterior.
No. This 9 is on the interior. 4 is in the
Oh,
exterior.
it's 9.
Okay, I'm going to show you something right here. Watch. Again, it was helpful if this is not here. Uh-oh. It's helpful if that's not here. You agree? See this line right here. Now, what I'm trying to show you is this right here and this right here. Hey,
Okay.
stop interrupting me.
Yes.
You see what I'm saying, right?
Yeah.
Now, if I talk about this guy right here and this guy right there, one's on top. They're both on top, but one's inside, one's outside. All right, I think that's a good way of looking at it. Pretty sure. All right, so I can move forward now, right? All right, let's talk about 25 through 33. All right, 25 through 33. This one's kind of annoying, so I'm going to blow it up a little bit. And we're just going to do all of the angles. All right? You can look at the picture and help me. So, angle 11 is 62. So I'm going to put a 62 in here. And then do you guys, that's 62 degrees. And then what was the other one?
14 is
38. 14 is 38 degrees. Now, I didn't really mention this, but I thought you guys knew. That symbol just means what? They are what?
Parallel.
They're parallel, right? So I've got 62 and 38. Now, in my opinion, I always just do vertical angles, all right, to start out. So if you don't mind, here's something else I just feel like doing here. Hopefully it won't take me that long. All right, it's just, to me, it's easier to get rid of those numbers. Everybody agree? Then I can just fill them in. All right. So let's get this. Okay, so now that I know those are 62, all right, and 38, here is what I'm hoping you do, all right? Again, I like to do the vertical angles right off the bat. So I know this guy right here is 62 degrees, and I know this guy right here is what? 38. 38, okay? Now, I also like to do the supplementary angles. All right, so if this is 38, this right here is 142. Does everybody agree with that? That's not hard. All right, then this down here is obviously 142, right? And then 180 minus 62 is?
118.
Thank you. That's 118. So this guy right here is what?
118.
118. Okay. Now you have to review the fact that the lines are parallel. So you should be able to tell me this angle right here is what? 62. Thank you for that. That's 62. So now let's look at the vertical angle. What would the vertical angle be also?
62.
There you go, right there. Okay. So now what is this angle right there? 38. Brilliant. So here we go. Let's put in 38. And then we go to the vertical angle, which makes it what? 38. Okay, now I need help with this guy. What's this angle? Tell me. Good job. How'd you get that?
So I added up 62 and 38, which is 100. And then it's 80.
The rest of it's 80.
23.
Beautiful.
So the
80.
vertical angle is 80.
And then the other vertical angle is 80 also. All right. Well, I don't think that's that hard. Right? Yes, sir.
This is kind of just like a question for like on the test. So I get all this stuff, like how to figure all this out, but on the test, I don't know if I'll be able to put like what like postulate or like theorem.
That's what we're getting at.
So we're gonna work on this.
No, I'm not. Yeah, I'm not making you write that out. You're not writing a postulate or theorem for that.
Okay.
All right. You should be able to tell me what the corresponding angle postulate says. That if you have two parallel lines cut by a transversal, then the corresponding angles are congruent. That's what that says. Then you can also say if you have two angles or two lines that are parallel cut by a transversal, the alternate interior angles are congruent. That's all. I'll show you. We'll get to the proofs. All right? But we just used our knowledge of those, just like we couldn't say 62 was 62 unless we knew that it was corresponding, right?
Yeah.
Yeah. All right, I'll show you, I promise. We're getting there. All right. Now, because I do want to work on the proofs, let's just talk briefly about 34, 35, 36, 37, 38, 39. Those are just writing what? Equations. All right. So on 34, what equation could I write? Tell me. Exactly. X plus 12 equals 114. Does everybody see that? Right? Because these are, uh-oh, that's not correct. Sorry. No, it's X plus 12 plus 114 equals what? 180. Because again, this is an acute angle, and this is what? That's how I used to do it. That's just how I do it. I know they're either equal or they add up to 180. And how do I tell the difference? I look at the size of the angle. Right? If they're both obtuse, they're equal. If they're both acute, they're equal. All right? Now, I can say automatically that y is what?
114.
114. Now, remember, I didn't want to combine the x and y because that would be a system of equations. I don't want to do that. Is everybody okay with that?
Mm-hmm.
All right. So now, let's take a look quickly at 35. All right? Now, someone tell me, we're not going to solve it. Just tell me the equation. Carson.
3x minus 15 plus y.
No, we don't want to group the x with the y because then we can't solve it. So 3x minus 15 is equal to what?
105.
Yes, because they're corresponding angles. Right? So you just write 3x minus 15 equals 105. All right? Now what's true about 105 and y plus 25? They equal 180. So if you wanted to, you could say y plus 25 plus 105 equals 180. Everybody agree with that? Can I say there's a relationship between this angle here and this angle right here? No, there isn't a relationship. They're not like alternate interior, there's no name for those. All right?
How would you know to put 105 with y plus 25?
Because one's obtuse and one's acute.
Oh.
That's how I do it. Very easy. Just like on 36. What's true about 2x and 54? They equal 180. Because one is what? One is acute and one is obtuse. That's how we're doing it. All right? So let's look at 38. What's true? Give me the two equations. Someone who's not saying much. Someone tell me about 38. Thank you, Ava. What are you thinking? Yes, it does. All right. Yes, it does. All right. Actually, I'm sorry. I made a mistake. It's not true because this is a little bit tricky. So watch. Look up here. We don't know that this is parallel to this. We don't know that. You with me? So I can't make any conclusion about opposite angles. You hear me? So 2x is equal to what, though? Yes, it is. And again, notice how much easier, and I always tell kids when you're taking your test, you might as well go ahead and draw it out, and it's much easier to see. Does everybody see how it would be easier to see if you just extend the lines? I hope you're listening to me. I hope you're listening. If you extend the lines, it's easier to see those are alternate interior angles. If I go down here and extend this down now, too. All right, it's easier to see. Just like it's easier to see that these two are called what? Consecutive interior. Thank you. All right. Remember, if it was corresponding, 5y would be up here. Right now, why is that hard to see? Because again, this is not drawn, and this is not drawn, and this is not drawn. You see what I'm saying? It's much easier if you just draw out the rest of the figure. But because they didn't draw out the figure, kids thought it was very hard on the test. All right, so if you're paying attention, you'll know to do that on your test. Draw them out. All right. Okay, let's try this proof now. Now, we're going to prove theorem 2.15. I don't even know what theorem 2.15 is. All right, so I'm going to flip back, and I think I listed them all for you.
Consecutive interior.
We're going to prove that if two parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. All right? So the consecutive interior angles are supplementary. That's what we're trying to find out. All right? So let's see if we can do that. All right, now I think this is what you were trying to say, Parker. All right, so here we go. Let's see. All right. Given, what's true?
N is parallel to N.
Yep.
And then L.
That is exactly correct. All right, so I'm going to fill that in. I'm going to try to anyway. So that piece is going to go right there. I can't make it, it's too big. So I have to write it. Now I wouldn't be lazy on this part, guys. M is parallel to N, and L is a transversal. What?
What is a transversal?
Welcome. Transversal is the line that cuts through the two parallel lines. That's all that means. You with me? This up here is also a transversal. All of these are transversal. They don't have to be parallel lines, which we will always see. Here's two lines, right? There's your transversal. All right? All right, here we go. What's next? Why do angles 1 and angle 3 form a linear pair, and 2 and 4 form a linear pair? Why is that?
Definition of a linear
Yeah, I'm really happy with that, guys. That's exactly correct. Very good. That's what the linear pair says. All right? All right. Now, if two angles form a linear pair, then they are supplementary. Now, do you remember what this is called? Now, I don't even know if I've even told you this. But there's the definition of a linear pair, all right, and then it's called the linear pair postulate. Is that us? All right. Wow, we didn't get finished today. All right. Well, this is our last one, right?
Yeah.
Okay. So your job for me is try to finish that up, and then tomorrow I'm collecting the homework. How's that? All right. We did most of it, but I'm still going to collect it. All right. Thank you, guys. I thought it was a good day.
Thank you, Mr. Brown.
All right.
Mr. Brown, can you get those papers?
I think it's